Before entrusting ourselves to experiment with the magnetic field, some magnetism notions are required. Where does magnetism come from? Around the atom's core are located electrons. These electrons are moving very fast, and one of their properties is the spin. Indeed, they are rotating and creating a magnetic force. This force has two poles, a north and a south one. The magnetism is directed from the north to the south, following force lines and taking the form of a field, inflated at the edge and making a cavity when it is closed from the poles. Actually, electrons are very small magnets.
The two poles of a magnetic object cannot be separated. If you break this object, two new poles appear in each fragment. Two opposite poles are attracted from each other. Two identical poles repulse themselves. There are several types of magnetism, and we chose to work on ferromagnetism and electromagnetism.
In the case of the ferromagnetism, we used permanent and R magnets. Their magnetic force is permanent because all the spins of the atom's electrons they are composed of follow the same direction. So the very small forces of each electron combine with the other ones to create a strong and fixed magnetic field, because the magnets are solid. With the electromagnets, the spins of the electrons of the atoms composing the solid are directed in various directions and cannot combine to generate a strong enough magnetic field. But if an electric current is put in it, it generates a magnetic field. It can be explained because the electric current is a shifting of electrons which make them create magnetism.
Finish him!
Our objective was to visualize the magnetic field. Here is how it looks like in 2 dimensions with a straight barrel magnet and iron powder. Using a compass and making it move around the magnet, it is obvious that the magnetic needle seeks the south pole of the magnet. Thus, the north pole of the Earth is actually its south magnetic pole.
To see it in 3 dimensions, we used a solution of magnetite oxide with colza oil and a very strong neodymium magnet. This kind of solution is viscous and attracted by magnetism. It is named ferrofluide. We had to wear lab coat because it is very steady. When set next to a magnet, the grains of magnetite are attracted by the magnetic field and follow the force lines of the field. This explains that it makes bristlet spikes and a dog shape. Just have a look at some results we had.
To see the cavity of the field at the pole, we diluted the magnetic with a lot of oil so that spikes couldn't appear. We can clearly see this cavity in these shots.
We talked earlier about electromagnetism, so we built an electromagnet with a coil, a direct current generator, a multimeter, and a variable resistance to control the current's intensity. In the coil, there is an iron core to catalyze the magnetic field. The more intense the current is, the stronger the magnetic field is.